Alrighty, I see that most people have their laptops out. Here we go. So I will do a quick refresh as well, just so for final people to catch up. Last we left off, after we read in our data frame, we had basically set, instead of just having one index in our data frame, we had a multi-index where we indexed based on gender, as well as that column that we made called age less than 10. And this was sort of the output that we saw, sort of a little bit crazy. But then we also, because of this multi-index, we were able to basically subset our data set based on those two indices, where we were able to specify which gender did we want to take a look at. We could take a look at male, and also we can look at age less than 10, true. And that's sort of the output that we see here, where the gender column or the gender index here is collapsed together to be all the males, and then age less than 10 is all true. And you can take a look at these corresponding values, the other columns in the data frame. And because we're able to, so moving on now, because we're able to subset based on a specific category of people that we are in our data set, we can also run any of those additional methods, such as taking the mean on all of these columns only on this subset of people. So if I were to just write, basically call on the males true, and then type .mean with numeric only, we'll then be able to do the average, right, on these values of those columns that we care about. And so then you have access to the age, the IQ, so on and so forth of that particular subset of data. All right, so that is one way to index into a data frame. I'm going to try to add something down below. There we go. Another way we can sort of do average statistics on these data frames is basically to try to average by specific group types. And so let's do it. We also have a method when we have a data frame. Let's go back to our subjects data frame. And just really quickly, as a reminder of what was happening yesterday, this was our subjects data frame. We actually have a different method called group by, where we can specify what group or which column to group by. And let's do the gender one just because there's fewer categories there. Gender, we specify this, and we run this, we will get an interesting output, where it's specifying, okay, your data frame is now a pandas.core group by generic data frame group by yada, yada, yada. Like this is the object that it returns. And this is a little bit more mysterious as to what the output or specific data frame now looks like. Whereas previously before we had the output be a very nice data frame. Now it's this sort of mysterious line of object-oriented code. So let me actually assign this to be a variable, gender groups. Give that a run. Great. Everything's running okay. Quick thing for you to be able to look is what happening underneath the hood is if I throw this through a for loop. So for the data frame in gender groups, it'll iterate over this new grouped by data frame. Let me just print what happens. Print the data frame that it's currently iterating over. And what you see is actually it's returning a tuple. You can sort of see the start of it right here. It's returning a tuple where the first index in that tuple is female, which is basically the category that was in that gender column. And the corresponding second item in this tuple is actually a data frame subsetted on that gender column, where all of this, you can sort of very faintly see, the gender is all female or reported female. If we keep on scrolling, because this print goes on very long, we see a second tuple in here where it's male as the first index, and then the corresponding subsets of the reported males from that data frame. And I believe we do have, nope, okay. We dropped out the nans based on that. Cool. Sometimes if you want to do, you could basically then do mathematics or statistics on this particular data frame by your subset. But because we sort of have the power to do additional methods on our pandas data frame, because it's a group by object, we have other options rather than having to iterate them over by loops. So I'm actually going to delete that just because that was more for visualization purposes. I'm going to actually specify which columns I want to average over. So I'm going to make a variable called averaging calls, just so I can have it all written out for me. Let's take the age column, IQ matrix, IQ vocab, our age normalized that we made yesterday. If you guys have reran your server since then and it hadn't run through all the lines of code, this might not exist, so just drop it out if you don't have it. And then also age less than 10 because we can. 10 as a column. And I want to average over these columns by the particular group bys we are specifying. And to do that, we can go gender groups, that group by data frame, specify the averaging columns. columns, and then do mean. So you can still do the dot mean or dot SD, dot whatever else methods you have for your pandas data frame in order to do some sort of average. And now you have a much nicer output where it's the average of the columns we specified by the categories that we decided to group by. And this returns the data frame as well. Yes? I believe so. You would have to make it an actual category instead of a null, sort of like a not an input. But yeah, so I would be like not reported instead of like an NA. And you can sort of see that the power of this group by ability, right? You can group by multiple different categorical variables, and you can take the average statistics of whatever you wish to in your particular data frame. And so just to really hammer it home is that now that you have this new output, right? This is looking very familiar when you print it out in console. You can also do the other loc. They keep on chaining these things. And specifically, I want the female row, let's say. Boom. And then you have those corresponding metrics for that particular row or whichever one you want. Like, right, you can keep on additionally subsetting and grabbing those numbers to use for other things or other reporting it, essentially. All right. Just to index group, make a really much larger group by subjects, and to give you an example of what the syntax would look like if you wanted to average over multiple things. Gender, let's say, and the age less than 10 column that we had. We do index group, averaging columns, just like above, but instead of doing one group by, we're doing two group bys, calculate the mean, averaging calls with an S. You can sort of, I'm going to try to, oopsies. Copy. I'm currently just trying to recover the previous mean with the one subset. There we go. So we can do a comparison of the two outputs. We have the gender for the first group by, and then we have for the second one, because I specified two grouping variables. We have gender as the first indexing column, age less than 10, false, true, right? Per the gender, and all the averaging statistics corresponding. You can sort of see this can get complicated or more and more complicated as you need it to be. All right. Any questions before I move on to the last little thing about pandas and hopefully jump into plotting? Okay, we're doing good. Moving this down. All right, so this is just us playing with one data frame. What if we have different data frames? I don't know, your software outputs subject demographic variables, sort of like this particular one, and then you have a metric outputted by your other software that does other processings. And then you want to put the two together, right? You don't want to actually stack the two tables together possibly because you have different column names, but you have, let's say, a column in your data set that is like subject, right? This subject has this demographic information. This subject has this analysis information. How do we merge the two? Well, there is basically an ability to merge two CSVs, two tables basically together in a sensible way so that corresponding values are duplicated so that everybody has its own represented information, as well as all these additional columns that we want from both data sets. And sort of that's a little hand wavy, so let's actually do it. So we're going to read in a new data set, pandas.read_CSV. And I'm going to cheat a little because I have this open from yesterday. I'm going to scroll up because this was a lot of typing, and I'm encouraging you to type a little less today. Going to copy how we read in the subject's data frame from yesterday. And people who weren't with me yesterday, feel free to just ignore me, or you can hopefully type quick enough that this will catch up, but this will be very quick. So I will just mostly demonstrate it. You don't have to do this if you don't want to. And I will change instead of subjects in that URL to nodes. And then delete that. Delete that. Index column is actually subject under subject ID. And we have use calls actually referred to by names instead. Subject ID, tract ID, node ID, and FA. And this is actually a data set tracked off on diffusion, tractometry. There you go. And essentially we're reading basic for every single subject, we have a tract name. We also have a node. So basically what point along that tract and its corresponding fractional fractional they're FA values. I hope people know what I'm saying. Anisotropy. There you go. Values. If I read this in, and if I type the URL correctly, yes, you can sort of see that we have fewer columns in this data set, where we have subject ID still as an indexing value, tract name, right? Left thalamic projection, right articulate. These are names of tracts. Node ID, basically what position along that tract we sampled, and the corresponding FA value. And so we can do the same kind of other informational grabs or like exploratory looks at this data. We can do that .info to take a quick look to see what, like I mentioned, the columns and what kind of data types they are. We can also use describe, but in effort of time, I'm going to just move on and show you guys the merge. And so if you remember, our subjects data frame also has that subject column right here. Subject, these are corresponding and they match. Okay. And how do we merge the two? Well, there is a function called pd.merge, where we specify which particular data frames, Panda data frames that we want to merge together. So we have our subjects one. We also have our nodes one that we just read in. And then we have to tell Pandas basically what column is the same column in both, right? So we have our indexing columns the same in both data frames. And so what we can say is left index equals true, right index equals true. And we're specifying left as the left or the first inputted data frame, so subjects, and right as in the nodes data frame. These also don't have to be the index. You can specify join on, I think it's on left and then the column name, and then on right, this corresponding column names. And yes, you can specify like a list of these columns. So say you have a subject ID that may or may not repeat for some unfathomable reason, but also like a group or some sort of like control versus some sort of testing group. And when you run this, basically, you get something that goes off the side of my screen. So I'm going to move it over, where you have just one subject column. You have the age, gender, handedness, IQ, and so on from the subjects data frame we had before. But also you sort of see tacked on the end here is actually the ID, the tract ID, node ID, and FA values. And these will be matched up by the subject or by the indexing columns that you specified. Yes.
Can you go back when you defined the nodes? Yes, we are getting an error.
Yeah, no worries.
Thank you.
And then you obviously can keep on joining. Like if there's more data frames, you can keep on joining. There's other ways to also join where you drop out missing values from the left or right, or you keep all missing values from left, right. These all should be covered and can be specified as additional arguments in the merge functionality. All right. I'm going to
again, what is left and right index?
Of course. No, you're good. So left, when we talk about merging, there's always like some sort of left data frame and then right data frame. Left in this case is the first one I passed in is subjects. So what index do I care about it? Do I care about the left data frame's index? Yes, it's true, because that's the subject identifier. Same for the nodes. It's ours also the indexes, the subjects, and I can merge on that.
So it's probably the same identifier.
Yeah, they are the same identifiers. Then you're going to need to manipulate your data to fix that. They do have to be corresponding, right? If there's no correspondence, it ends up just sort of putting the two data frames on top of each other with missing values here, missing values there. Like there's no correspondence to merge the two. All right. Hopefully the data set got read in, then the URL is fine. But in efforts of time, I'm just going to keep on going to the actual visualization portion. All right. So I'm going to close that and open up a new notebook. And alrighty. So we talk about visualization in Python. The most commonly used one, I would say, is probably matplotlib. You saw me use it yesterday if you were with me yesterday. Again, it's in reference to MATLAB. Basically, it's sort of built on essentially the functionality that MATLAB originally had, and people were like, I want to do that too in Python. Here, let's make a library that's called something very similar to MATLAB, and causes incredible confusion whenever I search stuff in Google. But essentially, you can load in the matplotlib, matplotlib.pyplot. You can sort of appreciate the naming scheme here. Sorry, pyplot with an O, as PLT, short for plot. Matplotlib, MATLAB plotting library dot Python plotting as your package / submodule that you're loading in. And the PLT is just sort of standard convention throughout the entire literature on how to call this particular submodule as well. Everything goes well if you've loaded it in. And so let's start talking about plotting. So right now we've been sort of interacting with Jupyter Notebook as just typing for math, reading in data frames, printing out nice pretty strings or data tables, and sometimes even brains. Well, in order to draw something, you first need a drawing screen, right? And in order to do that, we can specify fig, comma, x for axis equals plot dot subplots. You don't need to specify any sort of number or argument here. By default, when you run this, it automatically draws for you an empty figure, essentially. Where the fig variable here is basically the figure itself, where you can mess with its attributes after the fact. And this is x, or short for axis, to actually do the plotting, where you, along this particular figure axis, plot XYZ. And I'll show you a few examples that way. You don't have to start a subplots, like you can just start saying like plot, and just, throw random data at it. But it is pretty much convention to start off by saying, okay, here's my figure space, call subplots. So, okay, let's see. The best way to sort of play around with figures is to have some, playing data, some data to sort of mess around with. I'm going to start typing. Feel free to type along with me. You can make these the same values that I have, but don't be pressured to make them the same values. I'm just showing it because it is a nice, clear example of differences across a condition. So I'm going to make a variable called trial. List 1, 2, 3, 4, 5. First block. I'm also going to do a lot of spacing just so you guys can read it well, in case you need to. Some numbers, 50, 51.7, 58.8. If I typo enough and you guys can catch up with me, that's also be pretty nice. 7.9, middle block. Basically, this is sort of an experiment with multiple trials, some trials in a first, middle, and last block. And you'll sort of see how they differ in a little bit. 83, 84.2. Again, you don't have to type these numbers. Oh, yes, go ahead.
Is the 51 in the first block line, is that supposed to be 51.7?
Yes, thank you for my typo catch. $50, 96.9, 97.8, 98.1, 98.8. I'm a 98.7. All right, run it. Nothing. Thank you for that typo catch on Zoom. Again, they don't have to be these numbers. You can just sort of guesstimate and round up as you wish. I'm just putting them here because I have my paper to read off of, but feel free. So just explain what this is a little bit. For the first block, second, middle block, and last block, so 3 different conditioned blocks. We have 5 trials each. These are, if I remember correctly, I might not. These might be reaction times or something like % correct. I think it's % correct on some sort of experimental task. And so if we want to plot this, all right, let's start off with that fig.x equals plot.subplots to start off with a figure space. And we can plot on this figure space by specifying the axis we want to plot on and the kind of plot that we want to render, essentially. And so we can, on this axis, just plot a line, basically. So trial along the x is the first argument. Whatever values along the second, whatever values along the y is the second argument. And let's just hit run, see what happens. because I need 6 values. Right there, sorry, trials 1 through 6, not 1 through 5. There we go. Ta-da, a line, a very simple line. I mentioned previously before also by default, the last line in a cell will output whatever is the last output. If you want to suppress that, you can either give this a variable, give the last line of your plot a variable so that it'll get captured there. Or you can also, sometimes you'll see people do plot.show just to suppress that output. I like to do plot.show just to make sure I sort of have an end cap for my plots, but again, up to you on how you want to do that. Well, by default, or depending on your configuration, you can see that there's going to be a blue line on your screen. We can sort of mess with that by specifying additional arguments, as you would with most other plotting software. You can make it black. I'm gonna make it black just to be very clear. We can also plot additional things, right? We have 3 other conditions. This is with the first block. We can plot the middle and the last as well. Well, in most rendering of software, it is pretty similar. You draw one thing, you draw something on top of it, you draw the next thing on top of it, right? It's sort of a layered system. And so on this axis, I want to continue plotting. So plot trial, middle block. Let's do a different color this time. There's a lot of named colors out there. Your traditional rainbow colors are there, as well as additional fun ones. I'm just putting some nice, solidly dark colors up here, just so everyone can see it. I'm going to pick dim gray because I can. And then forget to end my parentheses on my plotting, but here we go. Oh, look at that. Condition 1, condition 2. There seems to be a difference. It's almost like they picked these numbers with a purpose. But now we can also plot the third block or the last block as well. The color equals dark gray. I spent all of last night going, why is dark gray lighter than dim gray? But it is what it is. And you can sort of appreciate, right? Very quickly, you can scale up on this, where if we go back to, let's say, referencing our pandas data frame, we can plot a column, XYZ, plot however many columns you want, and quickly scale up to an informative figure, hopefully. All right, so this is not all we can do. You see 3 lines, and if you read my code, you know which line is what, but that's quite annoying to do if we want to give this to, I don't know, a publisher, and they're like, oh, you want me to read your lines of code? No, that'd be nonsense. Let's give this an axis, give it a legend, so where the colors or the lines correspond to some sort of labeled indicator. And we can do that by giving the additional argument label. So let's label that first dark black line, first block. Label equals middle block. Label equals last block, the last one. Cool, we've given them a label, and I ran it again, but we don't see it plotted. That's because we need to add to the axis dot legend. Sorry, would you mind repeating that a bit louder? This one?
Yeah, the second one.
Oh, this one. Check your commas, check to make sure your strings are quoted correctly. What's the error, by the way? Oh yeah, there's also that too. Thank you, Ariel. Double check that you didn't do the same mistake I did, that these 2 things are at different lengths. Every single variable should have 6 values. There's also that as well. Right. So I'll keep on moving on. Where, okay, now we have a label, and now we've plotted that corresponding legend as well, and it will plot in the most sensible place as determined by the underlying thing. But you can also change the location. For now, the bottom right-hand corner seems appropriate. We also have unlabeled X and Y axes. And as my old graduate school advisor told me, I do not understand anything without a label. And I've gotten yelled at a few times for that. Let's give them some labels where we can put on that axis, set the X label, right? Set the X axis label, correspondingly set Y label. And yes, this was % correct. Give that a run. And there we go. We have an X axis label and a Y axis label as well.
Sorry, I have a question.
Yes, please.
So what would be the advantage of doing, because I have learned how to do this kind of like plots, but doing it the other way, when you just put the plot dot figure, for example, and then you begin to plot everything, not with the AX. So I wanted to ask you,
Mm.
what would be the advantage of using the AX instead of using the other way that I know?
Yes, perfect, great question. So right now we're in the, let me repeat the question or repeat the context for everyone else in the room. Where the person on Zoom, sorry, I can't see your name right now, is saying instead of doing X or axis.plot, just do plot.plot, right? Call on the library, plot the thing. And it'll do basically essentially for this kind of figure, the same thing. The benefits of doing it or learning to do it this way is the fact that we can actually specify multiple subplots. Right now, we're working on just one of them, which is fine. So there's only one axis to correspond to. But in a little bit, I'll show you what happens when you want to do like, right, plots multiple things in a tile. You'll need to be able to specify which axes you're referring to. And if you just do plot, it will just plot on the last thing that was rendered. It won't actually specify across all the subplots.
Okay, thank you.
Of course. All right, making sure everyone's caught up, everyone's still good. You also sort of appreciate that I'm literally just adding additional annotations, little nice fun things to do for every single plot. And rerunning the cell every single time to make sure that what I want is actually on this image. Making plots is a pretty iterative process. And you're right, you can change the color, make it like maybe this color scheme was not great. And I was like, I messed up. Let's go back, see if it looks good. Right? This is just sort of how we make figures in a sort of slow and methodical process. All right. Any questions before I start? I'm also right now entering to give us some more space to type in a second. Anything else? Any questions right now? Cool. In that case, I'm just going to show some other arguments that you might find useful, where we also have a marker argument, and then we can give it a few set strings. So right now I'm going to give the black or the first block a marker of a O. And that'll give us little dots at every single trial point. And so let's specify a different marker type for every single one of these lines. We have a downwards triangle, if I remember correctly, with a V, and marker equals upwards caret for an upper triangle. Give that a run. And then you can sort of see, right, you can add markers, these can be hollow as well. I forget the exact symbols, but the documentation in MATLAB you can see the confusion here. In Matplotlib, their documentation will also have what these corresponding markers mean. And then last but not least, in case you cared, there is also like line style, right? Instead of a solid line, let's do a dashed line. That's 2 hyphens right there. Let's add some more line styles everywhere for fun. Line style, all one word. I also have this problem where I spell style wrong pretty consistently. All right, cool. There we go. Pretty nice looking figure. All right. Any questions, or do you need to scroll up a little? Yeah. If it looks a little different from yours, I did do an enter between the lines so that my arguments don't roll off the right side of the screen. Okay, let me know when I can scroll down. People are still typing, so I'll wait. I got a thumbs up. Small point, I don't know if you can actually see it. I'm going to zoom in as much as I can. Remember when I said that the plots are actually layered? You can sort of see by the way that the first trial all has the 50 as the starting point. You can see how it's layered, right? The black one's on the bottom, the mid-gray one's on top, and then finally the light gray is on top. So if you do any sort of transparencies, if you ever want to do that for your plots, that also corresponds, right? They will lay on top of each other, and that's how the final product will look. Okay. So this is me typing out actual values to plots. And I sort of made the illusion also with the pandas and the data frames before. It's sort of annoying to type out every single one of your positions that you want to do this, but most of the times we read in data from elsewhere. So let's actually load in. Oh, yes, there's a question.
Yeah, this is kind of different, but just zooming into the figure, it looks somewhat blurry. Is there a way to like edit like the resolution of it?
Yes, there is. So this is right now just being rendered in Notebook, right? Actually, when you also save it or export it, it will change resolution as well. You can specify the DPI. I believe it's fig.save, fig.save, temp.png. Fingers crossed that worked. Refresh. Was it not save? Save fig. Oh. Plot dots. Plot dot save fig? Fig dot save fig. Save fig. Again, you can sort of see my MATLAB showing through. Save as is something else. So right. Here's the figure. Yes, the resolution is not so great if I zoomed in like that. I'm saving as a PNG right now, so that also is a thing. You can save it as a vector format as well. But I believe if I pull up the DPI, refresh that. Haha, now it's huge. We're getting a little better, right? We're increasing the resolution. You can go up as far as this PNG will hold. But keep in mind, if you increase your resolution, you're also increasing the file size, and sometimes some papers hate you for that. So be careful. I'm commenting it out just so I don't keep on saving it out every single time. And it can, Matplotlib can support other picture formats if that's your journal's preference as well. And I made an allusion as well to like SVGs, EPSs, so vector like file formats. Those can also be rendered as well. All right, so back to reading in data instead of typing it out. Let's actually read in another pandas data frame. So import pandas as PD. And hopefully, if everything went okay last night, in the curriculum folder, under Chang visualization, there's a little data folder with a CSV in there called visualization.csv. We're going to read our way through. Hopefully everyone's server reconnected and that's there somehow. So we can go data frame equals pd.read_csv. And let's give it our local path. So currently I am in my working directory, which was where we were in the beginning. Going into curriculum / Chang visualization / data. Maybe I shouldn't have nested it so far. Utilization.csv. Just going to read it, just make sure I got the path. Nope, I do not. One of these things is spelled incorrectly. And we're going to find out. Curriculum. Go in. Chang visualization.
Visualization.csv.
Yay, yay after the U.
You
there.
got me. You got me. Thank you guys. Never name your CSVs such bad words. All right, cool. And the other thing to specify is index_column. The indexing column is the first one because I have subject IDs as well in my first column. I'm going to leave it here just for people to grab the path. Thank you guys on Zoom. And one little quick thing, I believe I forgot to filter out the NAs, so let's do it together. We can also chain up, like I keep on saying, right? The dot methods, you can keep on chaining these up. There's a drop NA method, and it'll just drop NAs or drop basically any row that has an NA in it. And this will serve fine for our purposes. So actually, this is the data frame we were reading from the pandas lecture before. I was wondering if people would show up that wasn't in the last one with me. So I had to make the CSV just in case people didn't want to do all that merging. So this was actually the same data frame I just showed previously a little bit ago. And maybe because I wanted to finish up what I was doing yesterday, we're actually going to do a little bit of grouping by math on this data frame as well. I'm going to make this data frame head so I can actually see the bottom cell when I type it in. Let's actually group the data, as you can sort of see it here, by age groups. And we're actually going to be plotting the tracks. So these different tracks in your brain based on the fusion data. I'm going to be plotting the FA values for these guys. So let's split the data into two groups, younger folks, and then slightly older folks based on that age less than 10 column. So age groups as a variable equals data frame group by. And I'm going to group by those columns that I just specified. Age less than 10, tracked ID, spelled correctly, and node ID as well. I'm gonna move up from that pathing. Hopefully everyone's got it by now. I'm gonna move, oh, nope.
I'm sorry, a
You're good.
bunch of us are having an issue with the file not found, even though it's in that folder.
Okay, at least it's there. One thing you can probably check is if you make a cell and then really quickly do that exclamation point to call on bash, you might actually not be at the home Jovan, like you might be somewhere in curriculum and then you need to relatively navigate your way there. Or worst comes to worst, you go into here, you go to the data and you copy the data and you paste it wherever you are. That's true.
That works. The total spreadsheet, let me do that.
True, yeah. So that's the actual rest of the route,
Thank you.
of course. So loads just the same instead of a relative. Okay, now I'm going to scroll down. Hopefully people's got the data. So I've grouped by these particular columns. And let's split them into the two different data frames that I was mentioning before. Let's do age groups. And then we can actually call on the mean, numeric only, numeric only. Oh my goodness, true. And then specify which index we care about. So for age group, we want it to be younger, so they should be true. Look, true. And then we want their FA column. I'm actually not going to save it as a variable just yet, so you guys can see what happens. So we have, actually, I'm also going to comment this first part out before and do this in chunks. My bad. Should do this more incrementally. Right, first we made that group by, so we have that grouping by data. And then we took the mean of the numeric columns. And because we've grouped by first, right, we have these indices of the age groups, which tracked ID they are, as well as those node IDs, right? We're not averaging, sorry, we're averaging across these group by categories that we have specified. And you can sort of see, again, the printing is trying to sort of impress upon you that these are being grouped together. And then we want specifically the first index, which is age less than 10 to be true. And then we want this FA column over here. So run that. And we have, so you see that the age less than 10 column or index has been dropped out because we've already subsetted on that. And then we have the rest of the columns, including the indices, but only one data type here. This is that FA column that I'm asking for. Again, this is actually 1, 2, 3-ish. 3 is commands in one line because of that continuous chaining of the dot methods. So again, this didn't take me one shot to do it. I did it iteratively until I got to this point. So don't worry too much if you can't get it in one shot. You can also, if I remember correctly, age groups, do the loc first. True, FA. Only if I spell age groups correctly. No, I guess not. My bad. You have to do the average first. I was hoping you can subset first. Younger, FA, assign that to be a variable. Copy, paste. Change younger to older. Instead of true, we turned out to false. And so now we have an older FA where it looks exactly the same, but trust me, you've subsetted it on the age less than 10 is false index. Yes.
That's true or false?
1 second. Let me print it out for you again. Age groups, that mean numeric. Right here, there's this indexing column. There's a false for if the age was reported to be false when the age was reported to be greater than 10, and true when the subject reported that their age was less than 10. And I also saw another hand here.
Yeah, I just when you were able to subset with both if they work with ILOC work in that situation.
ILOC is based on the numerical index, so I believe 0, and then you would specify whatever column FA was. I know them by name, so I went with the name of them. Yeah. Okay. And then last but not least, because, oh, yes,
Sorry,
go ahead.
One question, sorry. So at the beginning, we grouped by age less than 10, track ID and node ID. And why when we put the log, we only have track ID, node ID, and the FA is because I thought it was because of the numeric only part, but the track ID is not numeric either. So I'm just like, I think I'm
Ah.
confused.
No, you're good. So I specified age less than 10, the column, tract ID, and node ID to be grouping columns. So these will not be averaged over no matter what I do, besides the fact that they're also not numeric. These are grouped out so that basically for the true falses in age less than 10, tract IDs, whatever they may be, as well as the node IDs, whatever they may be. We're taking the values that happen to have those same values in our data frame and averaging over all of them, however many there are.
Okay.
Cool. And so, but that brings up a good point. What are we averaging over? In our case, if you sort of notice these data frames, subjects gone. We're averaging over subjects. Subjects who are, younger than 10 we're talking about the same track. We're talking about the same position in that tract. Last but not least, I want to plot. We're going to be plotting a lot of tracks, so I want to actually know which ones there are. In our data frame, we can see up here, the tract ID has a bunch of different names for these. So I'm going to grab from there the tract ID, and I want the unique ones. Dot unique is also another method buried deep in there as well. And so just to print and show you what tracks are available for us to take a look at, we have left, right, thalamic radiation, left, right, cortical spinal, so on and so forth. And there are some abbreviations in there that you can take a look at Jason Yeatman's work to figure out what they are. Okay. So we have a bunch of different tracks, and back to that original question about why do we care about doing fig.ax, that's because we're about to do a bunch of subplots. And so new thing, fig.x equals plot.subplots. But first, before I do that, I'm going to plot everything on the same thing just to show you how messy it can be. For tract in tracks, so for each tract we have, just remember that list of strings that I gave you. We can do x.plots. We can do from the younger group, younger FA group, we can plot the tract, give it a color of black, just so we know that is different. X.plots, older FA tracts. I'm referencing, right, that particular tract that we've subsetted out as an index. Color equals dark gray. I'm going to just do plot.show. Just this is a personal thing of mine, just so I know that's the end cap of the figure I want to draw. And we're about to see a bunch of them rendered out on the same plot. You can sort of see the dark black ones are from the younger group, and then the sort of lighter gray ones from the older group, and their corresponding tracks. But you can sort of also appreciate that I have no idea which one's what. They're all the same colors too. I just know the group difference here. So let's move on from this and try to plot them across different subplots. Before I move on, though, I am going to add some axis labels because I am going to lose myself in a hot moment. Where x-axis is actually node, so we're plotting along the basically which position along this tract as the x position, and the actual FA values are our y positions along these particular tracks. Okay. I know I typed quickly, so I'm going to stop for a second before I move on. Any questions at this point? Yes, please.
What is the sort of takeaway from?
Well, that is really a lot of squiggles, but well, the fact that, well, one, if you plot too many conditions in one figure, you're going to lose yourself very quickly. The only difference you can see here, right, is the color. I could also, like, for every single tract, do a different color pair, or for every single, oh goodness, there's a bunch of other conditions actually in here, or basically, I just wanted to show you what would happen if we were to do a for loop and plot on the same axis over and over again. There are other ways to split out different conditions in plots besides the ones I showed before: color, markers, line types. We also have facets, or basically different panels. And then we can also, of course, make multiple figures. Right? There's many ways to split across your crazy convoluted experimental condition if you wish to. Yes.
You wanted to have like colors to different tracks and then a legend for what color corresponds to what and how to like not overlay on top of there.
Yes.
I speak from experience.
Yes. You can definitely do that. I would have to probably do another variable where it's like, okay, or a dictionary, right? Refer to this key, to this color value that I want to do it for. It might be a little complicated though. But if you wanted to make a manual dictionary that has a key to reference, that might also work for you too. All right. Moving on. So before I get into a crazy complicated for loop version of it, let's actually just make manually 2 subplots for one figure. So fig, then x equals plot dot subplots. This is what we've been doing before. Now, instead of specifying nothing, we can specify how many subplots I want. So the first one is how many rows. I want 2 rows, 1 column. So in the end, though, 2 subplots. If I run this, you can sort of see this is the layout now, right? 2 plots for one figure. I can also flip this around to be 1, 2. So 1 row, 2 columns of figures. I do want the row configuration though. Another thing that is happening is actually the axis is no longer just, I'm going to force it to print. It's no longer just one thing. It's actually, if you look up here, it's a list of 2 things, right? Axis 1, first subplot, axis 2, second subplots. So you can either refer to it as x in the square brackets 0 for the first one, x square brackets 1 for the second one, and plot accordingly to what position you're in. You also see sometimes people take advantage of syntactic sugar, where you can actually do some spreading of variables. If I know there's going to be 2 of them, I can also do this. X, which would have been originally 1, gets spread into x1 the variable, x2 the variable, if I didn't want to do the subsetting method, like right with the square brackets. Again, personal preference on how you want to do it. This is sometimes something you see if you share code with some people. It does get much more complicated if you do like crazier configurations. So I personally have the preference of keeping everything as just X, just so I can refer to it by row column a bit more simply. All right, so how do we plot across these 2 axes like I'm mentioning? So instead of just saying it, let's just do it. For the first axis, let's plot younger FA. Let's pick one. Left R Q fit. I'm exposing myself with how badly I spell every single time I code. All right, cool. We have one thing on the first axis. We have the left articulate arcuate, oh my goodness, from the younger group of people plotted on the first axis. And to stop myself from spelling poorly, we're going to copy and paste and do older FA dark gray. Once again. Ta-da. Right, we're plotting only on this first particular subplot. I'm going to copy this whole entire block and then refer to the second one by changing the index. What about done? Plotting to the second subplot. I'm going to change it so that, I don't know, let's do the right arcuate instead. Keep the colors. We're doing pretty good. Plot.show, just a personal preference of mine. There we go. And similarly with the one singular plot, you do have to then specify, right, X label, Y label for every single one of these subplots as well. So X0, set X label to be whatever, so on and so forth. Okay. Let me scroll up a little bit just to show you how it's being split up now. You can also sort of appreciate it, the fact that the axis variable is iteratable. So instead of doing it manually, let's throw it through a for loop so we don't have to type this multiple times. Below, start a new figure x dot plots dot subplots. Let's actually, because we are here, I know this is because I know the data set. There are 20 tracks in here, so let's do a 5-row 4-column configuration. And also just to show you what the X variable looks like when you do something a bit more complicated. It's a list of a list of a list, right? It'll be some sort of crazy configuration. And sort of, it'll be in the configuration that you specify your subplots to be in. If you wanted to spread this, like I was showing you before, it gets a bit complicated. So that's why I typically tend to do just the X. Additionally, if you keep it this way, you can also access X axis.flat, which basically flattens it. You can sort of see it's now printing as a NumPy flattier. flattier object. Basically, now instead of having it to be specified by row by columns, it's now just one vector. And you'll sort of see what I mean when I throw it through the for loop. So personally, because I know it, there are 20 tracks plots. So let's go for I in range 20. So for each tract, 0 through 19, technically. Let's actually get the current tract. So tract equals from the tracks variable, right? The current index of the first guy or the second guy. Axis dot flat, and then we can just give it in linear index essentially. So instead of having to specify row 1, column 2, we can just go, oh, row 1, column 2 is 2. Row 2, column 2 is 7, right? It's just flattened it all out so that you can reference each one iteratively. And then same as before, plots, whatever you want. Tract color equals black, x dot flat, plots the older, FA tract. Please appreciate that I typed relatively quickly, but you can copy and paste from before if you've done this. I'm also going to be setting the title just because I'm going to not be able to figure out which one's what. Set the title, so there will be a little title on top of these figures of what tract it is, as well as we're actually, because you can sort of see from me just printing out the subplots, these axis values are just going to go like, they're going to overlay on top of each other because this figure is so small. So I'm actually going to turn that off. So for the current axis is, sorry, I'll scroll up a little bit. And then as usual for me, plot.show. Give that a run. Everybody's still on top of each other, but you, oh, sorry. More, okay. Sorry, it's a scrolling problem. You're welcome. I will actually back out one then, unless that's too small. Okay, that is too small. I was hoping.
Yeah.
No, you're good, you're good. The hassles of trying to show many large figures and also type at the same time. But okay, great. You have a title that is quite large and overlaid on top of you, everybody, but at least they're now all separated out. But you can sort of see that the younger and the older folks for their FA values differ sometimes in some places, but more particularly, but not in every single track that we have in this data set here. There are some additional nicer aesthetic things that you can do just so you can make this a bit more readable. One of them is definitely setting the figure size. So back up here in the subplots call, there's an argument called fig size, and let's just make it bigger. 10 inches in width, 8 inches in height as a tuple. I believe a list will also work. But basically, boom, it's now a bit bigger. Things are still overlaid on top of each other, which is not great, but I can also just keep on increasing that. I will scroll back up to the code part because you see this. There's also another nice thing in case you are able to, and you have a lot of things being shown on the same screen, is at the end, there are also figure properties you can mess with, right? So far, I've mostly shown you axis properties that you can mess with, such as setting the labels, and you can also just tick marks or take them off, so on and so forth. But you can also make the figure itself, the whole thing, we can give it a tight layout, which basically means squish everything in if you can. And everything is squished in as best it can. Now the titles are no longer overlapping, which is a great bonus. Any questions so far? I'm going to leave it on this code portion right here. If you wanted to be tricky instead of hard coding stuff, again, this is not necessary. For I and then tract in, remember that tracts variable we have? I'm going to show you an enumerate tracts, which basically this function will give you both the positional index as well as the name or the value of that as well. So instead of having this, comment that out. I still get the same thing. In case you didn't want to just do it by the numerical index, you also have other options too, if you wanted to very specifically plot the tracks by the tracks. Okay. Yes, question.
Having a plot.show and not having a plot.show.
Not too much of a difference in this particular case because the tight layout, I believe, also suppresses that output. It's a personal thing. I was taught this way, so I typically just do it this way. Again, it's not necessary. The figure itself will still render. It's just there's sometimes some of these calls will have output, like it'll print, oh, matplotlib axis is whatever. I just don't like saying it. It's a personal choice. All right.
Sorry,
So
can
these-
you go up? Sorry, can
Yes.
you go up a little bit to the part of enumerate?
Yes.
Okay, so we don't have to use the part of track equals tracks when we use enumerate.
That's right, because track, the variable itself is now also iterating, there it is, there's the word. Because it's a value from this tracks, right? All the tracks variable.
Okay.
Mhm.
One sec. I'm just trying to make that work, but I don't know why it's working here. Struct.
Did
I
you
don't know
catch
why.
the comma? The index variable has to come first because that's how enumerate populates out its iteratives.
Ah, okay. So I
Must
have to
come
use the
first,
variable
yeah.
again. Okay.
Okay, cool. All right, so this is just, a line plot with markers, different line types, different colors. You can mess with it how you will. There are definitely other plots in here. And you can do all the different kinds of cool layering that you want to. But in efforts of time, I'm actually going to move on. So just want to make sure you guys know there's scatter plots, there's bar plots, there's other things out there. I'm just showing you the basic plot function of matplotlib. And the documentation is quite extensive on it. But there's another kind of visualization package that people oftentimes use in Python. It's called Seaborn. So once again, importing time, import Seaborn as SNS. This is also pretty convention as well. Seaborn is sort of, how should I say, it's sort of a way of thinking more than a way of just plotting X and Y. It sort of requires a data frame. So it requires your data to be in some sort of data frame like object, and it requires it to be formatted such that it's long form, where every single column is something that will be plotted or averaged over in the actual rendered figure. And you'll sort of see what I mean in a second. The reason why I mentioned this is sort of belabor the point is that if you're coming from R and tidyverse, it's exactly the same kind of thinking where, right, you specify a column that you plot it, or you specify a categorical variable that you change across hue or color. It's the same kind of thinking. I am unsure. No, I'm pretty sure MATLAB doesn't have that, which is a bummer. All right. So Seaborn is sort of like a tidyverse way of thinking if you are familiar. If not, let me show you what I mean by that. So let's actually sort of make our data frame a little bit smaller so that we have something to work with that's a little bit more manageable. Oh, my bad. I'm going to type a keep calls. Keep call, which columns to keep, just so I have something smaller to work with. Handedness, age, gender, handedness. You've seen these column names before, so I'm typing them relatively quickly. This is like the first 1, 2, 3, 4, 5, 6. You can also write subset our bigger column, I think, as well, just by these few variables, and then do df drop duplicates, but keeping keep calls. Let me just print out this new data frame. Yeah, there we go. Where our subject ID is back, but we sort of removed. Whoop. Did I type this correctly? 1 second. I think I did. Cool. Yeah. Duplicates have now been dropped. And the main few columns that we really care about are these front few right here. Again, don't worry too much about this portion. I'm just subsetting the visualization CSV I made you guys read into something more manageable so that I can plot it pretty quickly. I'll leave it up here for a few more seconds, but I will do, printed a lot. It printed a lot. Dot head, just so I can see the bottom cell. Oh, the other ones, the ID and the track ID. You sort of notice that in the big original visualizations one, there actually is a bunch of tracked ID for one subject. But now if you look over on this subsetted one, there's only one subject and then there is one value and one specific value, node 0. It's the first one it caught that was not a duplicate. Everything else was dropped.
But in mine, I only specified origin and handedness.
Mhm.
And then it's still giving the same output. as you have.
The same output that I have.
Yeah, so like, I was like, oh, I'll just be quick and then. it's like,
Oh, yeah.
still giving me 9.
It's because it's dropping duplicates based on those columns.
Oh, okay, so it's not only, you're not
Yeah.
only selecting.
Yeah, you could be more brief about it. I want to be pretty explicit because I was like, okay, these guys, just so I can plot it quickly. Okay. All right, so let's make a bar plot with some of these variables here, where we have, let's say, handedness along the x-axis and IQ along the y-axis. How will we do that in Seaborn? Well, Seaborn, the bar plots, specify the kind of plot you want, and then start giving it a few named variables. Where is your data coming from? Data equals subjects, this new variable that I just made. X equals, like I mentioned, handedness. I'm not actually calling the column, I'm calling the name of the column here. So this is just a string. Y equals IQ. And then I think that should be enough. Plot.show, just because it's on underneath the hood, it's still all matplotlib. There we go, really quick bar plot, where handedness is on the X and IQ is on the Y. Right, so the way of thinking is that for this data frame that we have, take all those values and then Seaborn will figure out how they're categorized, essentially. They'll basically do the splitting for us, we don't have to do it, instead of having to do, let's say, a for loop over the tracks. Of course, obviously, if you get a little bit more esoteric in your figure making, Seaborn can't handle everything, but these basic ones, they can handle pretty well. There's other ways you can categorize this, right? There's other arguments that you can specify a split. We also have hue to specify differences in color. Let's add in gender. And really quickly, without me having to do much, without me having to do any sort of subsetting or grouping by, it gives me the average of these particular groups. And it also gives me, I believe by default, a 95% confidence interval right there. So really quick, defaults are pretty nice. And all I had to do was specify which column goes where into what particular order. And so you can sort of see why people quite like this particular package as well. But again, it doesn't have the world's biggest extensive library of crazy plots, although it does have quite a few nowadays that I do use regularly. Other fun things you can do, you can specify a palette. So if you didn't like this blue orange configuration, oh my goodness, set one, I think is the name. Yeah, okay, red, blue, whatever you would like. There's a bunch of color maps in here that may be pretty consistent across other coding languages as well as matplotlib. You can look those up and you can sort of just specify them by name. Other fun things, because maybe just because I'm here and I want to match the rest of my figures, you can also do sort of crazy specified versions of my black palette that I've been using consistently throughout. Again, up to you. This is more aesthetics than anything. All right. Just to show off a little bit of the other kinds of plots that can be made with Seaborn. Hello. We also have the ability to specify which subplotting axes we have as previously before. So let's do fig x equals plot.subplots. So Seaborn plays very nicely with matplotlib because Seaborn is dependent on matplotlib. Let's do 1 row, 2 columns. Subplots with an S. We also can make a Seaborn swarm plot, and you'll sort of see what that means. Looks like a bee swarm. That's what it's sort of implying. Where we have data equals from our subjects data frame, X equals, oops, sorry about that quick run, my hand slipped, handedness, Y equals IQ, and let's leave it at that for now. And I'm just going to end. Come on. I'm just going to end it with plot.show just really quickly to show you what happens. Someone referenced before, it's like, why do we want to call on axes? Well, that's because whatever the last subplot is, if you just plot, which is what Seaborn does underneath the hood, it plots on the last one. So if I wanted this swarm plot, which you can sort of appreciate is the data points plotted out with a little bit of jitter on the X, a little bit of jitter on the X so that you can see all the data points, sort of like, again, a beehive of the handedness on the X and IQ on the Y. It is on the right-hand side because that was the last subplot that was called. It was the current active axis. So in order to specify which one we wanted to plot it on, like the one on the left, additional argument x equals x, our actual variable, and then subset which one you want to plot it on the left-hand side. We can also put on the right-hand side on this subplot, another different kind of seaborn plot that's also pretty common. It's called a violin plot, violin plots. I'm actually just going to copy and paste my input arguments here, paste, get my indentation all nice and neat, and then change the axis to the one on the right. Plots, and there you go. So you can sort of see that there's different ways to plot that are sort of base native to seaborn. These are some quite nice ones to take a look at as well. Additionally, like changing the hue, palettes, specifying the size of this figure can all be configured through all the arguments I've shown you previously as well. Something may be really fun because I'm plotting the same data just to show you guys. You sort of notice I copy and pasted, and because all these are named arguments, we can do a dictionary for a keyworded argument call. So in case you cared, where data is our subject's data frame, our X was our handedness. I'm making a dictionary right now, specifying what argument has what value. Y is our IQ. Get my strings right. And so instead of having to do this really long call, especially seeing as how we have the same kind of input arguments, with the only difference being our axis is on the left or right, or the first or the second argument, we can change this up and provide the same arguments twice with some keyworded arguments or some syntactic sugar here. Quargs with an S. There we go. Just to clean up my call a little bit nicer in case that was something that mattered. I can also change and add a hue here for funsies. Oh, I believe there is nope, too many things. Just do handedness again. Yay, look, my legends. Changing the colors, right? I will scroll back up to the call in case you cared about this sort of shortened call. And of course, this is just an example where these two subplots are showing the same data in the same kind of configuration, but you can sort of imagine you can do this in a bunch of different ways as well. You can still specify individual arguments for different data if you cared. Any questions so far? See a lot of squinting, so I made the font a little larger. You're welcome. I also have really bad eyesight, so I appreciate the challenge. Please note that seaborn sort of depends a little bit more upon the fact that you understand what kind of plot these are and what kind of data can go into it. So, right, for like a violin plot, it sort of expects like Y is a continuous or some sort of, continuous like variable. And that X, I believe X must be a categorical variable, right? This kind of distinction should be known to you, and it will throw errors at you if you don't specify the correct kind of data column, if you want to make these kind of plots. Okay. I'll scroll back up later, but let's keep moving forward just so I can finish off. Another kind of plot that you might also want to really quickly take a look at your data is we have box plots as well. SNS, box plot. Give my enter in a correct position. Data equals subjects. Let's specify some different columns this time, just so you can see. Oh, nope. My example was showing the same columns. Just because I can. Oh yeah. Really quickly, maybe because I saved my stuff in a dictionary, I can also really quickly call other different kinds of plots to show. So you can pick and choose your favorite. Again, this is more of an example of what other kind of plots are out there. The documentation in seaborn will also be pretty explicit. There's also a gallery, I believe, that shows you the different kind of plots and things you can do with this package. This was the one that had different arguments, my bad. So we also have Seaborn LM plot, which is basically a linear model plot, where we can specify, instead of having categorical variables along our x-axis, we can have a continuous variable along our x-axis. And this particular plotting function, plotting figure rendering code, essentially has other options for you as well. I'll sort of show you what I mean. Give it our data, give it our x. Let's do IQ matrix this time. So one of the IQ metrics that they measured with this particular data set, IQ vocab along the y. Q equals gender to do another split. And then plot show. We can have different kind of linear model plots. So like a scatter plot with the regression line fitted to it, as well as some confidence intervals along the alpha. And pretty quickly, you can make very complicated plots with other fun things to split upon in this way. All right. Yes, if I may. LM plot, all one word. All right. That's pretty much a tour de force through most of the plotting languages that I see that are commonly found throughout Python, and however you want to use these things. I oftentimes play around with the color maps. So this is not my favorite color map in the world. Feel free to do whatever you want with it. Feel free to explore the other arguments that are available specifically for every single plot type. There's quite a few of them that you can mess around with. Some of them may or may not work depending on if that is configurable in that specific plotting plot figure. But other than that, if you have any questions or other things that you want me to scroll back up to in case you missed it.
Yes, please. Can you repeat the part of the lists when you created the list and you
the keyworded one, this one right here, or something else?
Yes, that part. So it literally we just have to we just put the AX equals AX, and we just have to assign to which image, which figure subplot we want to assign it, and then we just put the I don't know how you call that, stars, and
Yes, 2 asterisks. Yes.
yeah, asterisks, sorry, 2 asterisks, and then that's it. So whatever we put there, for example, can I do it in three-dimensional way, like put a Z as well and create another kind of graph as well, or not?
Yes, so like let's say you do another subplot and like do 1 out of 3, and then you do another one, you can keep on adding to it. But remember, when I was typing this all out manually, I was specifying each argument by its name and then its corresponding value, right? Across these 2 plots here, they're the same, right? This is the same data, just plotted in 2 different kinds of plots. And that's why this is, a quick way to not prevent myself from typing too much. This also works for other functions too, by the way. This is not just for plotting functions. This is for all Python functions. This is mostly because I was typing the same thing over and over again. And the only difference in the actual argument call is which axis these went to. So that went first. And then all the similar arguments in this dictionary here were placed at the end.
Okay, great. Thank you for that.
Of course. I believe John covered it in his advanced, but I also like to not type that much, so I stole it from him. All right. Any questions? Yes. Yes, I believe Seaborn has a core maths function, XY, same thing. I think it also can just take a NumPy array or a pandas data frame. Because people do this really commonly, it just has a really nice output. Of course. Well, it's actually, we have a few seconds. Documentation. Watch me spell documentation wrong. Gallery is what I like to go through. Look at all these pretty plots these guys can make. If you click on them, here's some code. I commonly come to this page and I commonly rip these bits of code from my own stuff. So if this is not all I can show you, right? Here are some KDE plots. Here are some horizontally spread ones. Here's some image ones, a random cluster tree map, right? Bunch of different options. Gallery view is your friend. It'll show you a quick rundown through what's available for this particular package. Matplotlib also has a similar gallery page as well, in case you didn't want to scroll through all the docs. I do find these quite pretty too, so it's nice to look at. All right. With that gift of time, you're free to go to lunch. I believe I actually managed to cover most of the things in one go.